Hello, my most favoritist pre-calculus people. This is Unit 7, Lesson 3, Sum of an Infinite Series in Sigma Notation. Some more formulas to add to your list here that you've got. The sum of an infinite series. If the absolute value of r, that's your quotient, your ratio, for a geometric series, is less than 1, then the series converges to the sum of s is equal to a sub 1 over 1 minus r. Let me correct something real quick right here. Infinite geometric series. Let's add that to our notes. Geometric series. There we go. That's better. Yeah, it does have to be geometric. Okay. So anyway, your formula converges to the sum of s equals a sub 1 over 1 minus r. Okay. Notice that here the s does not have a subscript of n. Okay. That's because with an infinite geometric series or any infinite series, there is no n. Okay. N approaches infinity. N keeps getting bigger. Remember, n is the number of terms, and your number of terms keeps getting bigger. It's a series that never ends. For that reason, you don't really have a sum, but you have a number that we can find in which the sum converges. Okay, so this number s right here is going to converge to a sum. It's going to get really, really, really close to the same number, and it's close enough that we call it a sum. Okay, so no subscript on this because n is approaching infinity. Your number of terms is approaching infinity. Okay, so let's take a look at this example right here. We're going to find the sum of 9 minus 6 plus 4 minus dot dot dot. Well, the dot 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 says that it's infinite. Okay, if you divide out these numbers, if you say negative 6 over 9, okay, your next divided by previous, 4 over negative 6, you do get the same number, negative 2/3. That is your r, your ratio. So I know that this is a geometric infinite series. Okay, it's geometric because we have an r. It's infinite because we have a dot dot dot. Okay, so all I'm going to do is just plug this into that formula. I'm going to say that my sum is converging to a sub 1, which is my first term, 9, divided by 1 minus my ratio, which is negative 2/3. Okay, and plug that in your calculator and you get 27 over 5, which you leave as a fraction. If you want to make it a decimal, that's okay too. So that formula is pretty easy to use like that. Okay, now sometimes you'll get something that looks like this. It'll say, for what values of x does the series converge? So here, you know, we have this infinite series right here, and I can tell that it's geometric because if I put my next term over my previous, my x minus 2 over 1, and then x minus 2 quantity squared over the previous term, x minus 2, and then my x minus 2 quantity cubed over x minus 2 quantity squared, then I can tell that every single time that these ratios or quotients simplify to be x minus 2, and that is my r. Okay, so this says that we've got some series and we want it to converge. That means converge to a sum. Okay, and it is geometric. All right, so I know that my formula s equals, I'm sorry, no, not that formula, but I know that right here, oops, let me back up, right here, okay, my formula for the sum of an infinite geometric series says that the only way that it's going to converge is if the absolute value of r is less than 1. Okay, so I'm going to use that here. I'm going to say, well, in order for this to converge, then I need the absolute value of r to be less than 1. Well, r is x minus 2, so I'm going to put x minus 2 in those absolute value bars, and I'm going to solve this. Okay, so the reason I'm solving this is because I want to find the value or values, could be more than one, in in which I can plug a number for x into this series and it would definitely converge. And I'm trying to find those x values, okay? So we're going to solve this absolute value equation. And if you remember early on in the semester, I gave you this little thing to go by for absolute value equations. If you have a less than, okay, then you're going to use the word and to write a conjunction so that you can solve it. So less than. If for some reason this sign were to get switched, and it could if what's in front of this ever was negative for some reason, then greater. So I gave you this little thing right here to go by so that you could remember what to do with absolute value inequalities. But less than, greater. So if you have a less than sign, you use the word and. If you have a greater than sign, you use the word or. So since this is less than, we're going to use the word and. So we take the x minus 2 out of our absolute value bars, and we just write x minus 2 is less than 1 as usual. Use the word and. Then we write x minus 2, and we switch both of these inequalities, both of these signs. The inequality signs becomes greater, and the 1 becomes negative 1. Okay, so hopefully that's just a review, and you remember how to write this as a conjunction, how to write absolute value inequalities as a conjunction so that you can solve them. So I'm going to add 2 to each side. That gives me x is less than 1. And, ooh, that's a mess, isn't it? And, there we go. Add 2 right here. And that is going to be x is greater than 1. And that is so not a 1. That is a 3 right there. Let me fix that. Okay. So what this tells me is that my lower number is 1 and x is greater than 1. That means 1 has to be less than x. And this right here tells me that x is less than 3, so I can just add on a less than here. Okay? So what I've done is I've rewritten this way without having to write the word and. What that tells me is that x would have to be between 1 and 3 in order for that series to converge. If x was anything other than a number between 1 and 3, that series would not converge. Okay? All right. Let's talk about sigma notation here. This symbol right here, sigma, represents the sum of a series. You've probably seen that symbol on some fraternity houses around the college and all of that before. Okay, it is a Greek letter, all right, and in math it means sum. Sigma means sum. All right, so right here, if I'm looking at 1 to the third plus 2 to the third plus 3 to the third plus 4 to the third plus 5 to the third, then what I'm noticing is that I am adding up a series, and I actually want to know what the sum is or what the number is. Well, the way I can represent that is I can say that my sigma is going to go from the number of terms where n starts at 1 and goes to 5, because I have 1, 2, 3, 4, 5 terms. So n starts at 1 and it goes to 5. Remember, n is your number of terms, okay? And this is called your index of your sigma notation. So this is where you write down where n is going to start and where it's going to stop. Then right here you put the function that represents that series. Well, what I can tell is that, you know, these are my values of n. N is 1, then it's 2, then it's 3, then it's 4, then it's 5. And all of these right here, these numbers, they're the same number. So that number right there is actually n. And what I'm doing to n each time is taking it to the third power. So what this is showing me right here is this right here represents sigma, or the sum of my series. Okay, this right here, the 1 cubed plus 2 cubed plus 3 cubed and all of that, not this part, okay, but this actual part right here, all of that is what we refer to as the expansion of sigma. Okay, so right here, number 6, it says to expand the summation of 1 over n as n goes from 1 to infinity. Okay, so that's sigma right there, because I know I just threw out a new word on you. Okay, it also means summation, which is actually the word you would find in your calculator. Okay, yes, that symbol is in your calculator. Woohoo! Okay, so this right here, I'll say it again, this is the summation of 1 over n as n goes from 1 to infinity. Okay, and if we expand it, what we're doing is we're going to let n be 1. We're going to start it at 1. So 1 over 1 plus, then it's going to go to 2, so it's always consecutive numbers, consecutive whole numbers, plus 1 over 3, because we're letting n be 3. Now we're going to let it be 4. And we keep letting that happen right on out to infinity, so we just put a dot, dot, dot. So this is what it looks like when you expand this summation. Okay, now let's practice writing some of these as sums using sigma notation. Okay, again, right here, this is, I've got 5 terms here. Okay, and a lot of times students will try to always make n start at 1 and go to whatever, and they'll think, oh, I've got 5 terms here, 1, 2, 3, 4, 5, so I'm going to start n at 1 and I'm going to go to 5. And then they start playing around with this and they're like, now what can I do to n to get 4 that I can also do to n to get 9, that I can also do to get 16? Well, what I'm seeing here is I recognize these as my perfect squares. Okay, this is actually 2 square plus 3 square plus 4 square plus 5 square plus 6 square. So I'm thinking, you know, in order to get these terms right here, I want to take some number n to the 2nd power, which is right. But if I started at 1, I'm not going to get this. I'm going to get 1 squared on out to 5 squared. So this would give me a series that starts with 1 and ends at 25. I want it to start at 4 and end at 36, so I need to change these numbers. So I'm actually going to start n at 2, because 2 squared is 4, and I'm going to end it at 6, because 6 squared is 36. Okay, now look at this one right here. Okay, this one I can tell that it's going up by 6 every time. So what you can do with this is you can actually find yourself a formula for an arithmetic sequence. Okay, find yourself a formula. A sub n equals my first term 3. I'm going up by 3 each time. I'm adding 3 each time. Am I adding 3 each time? Okay, looks like it to me. Let's see what's going to happen here. Okay, I'm going to distribute. And what I get is 3 times n. Well, that makes sense, because remember right here, these numbers represent a sub n. N is your number of terms. Which number is it? This one is my first term. This one is my second. This one is my third. Okay? So I'm going to see, well, does this really work? If n is 1, 3 times 1, is that 3? Yes. If n is 2, 3 times 2, is that 6? Yes. If n is 3, 3 times 3, is that 9? Yes. So it looks like 3 to the n is working. So my sigma, this time I do get to start n at 1. And it's going to go to some number, and my function is going to be 3n, what I found right here. Okay? Well, I have to figure out, well, how many terms am I going to have? Well, what number times 3 gives you 300? It would be 100, wouldn't it? So that's the number that goes right here. Okay? So remember, n, down here, you're going to write where n is going to start. Most of the time it will be 1. Sometimes you have a little bit of an exception like you did in number 7, but the majority of the time it's going to be 1. And then you got to figure out where it's going to stop. And then you got to check to make sure that whatever this is, and you can actually get this part right here using your A sub n formula. Okay, then you want to check and make sure it's going to work. So plug in a 1. 3 times 1 is 3. 3 times 2, 6. 3 times 3, 9. All the way out to 100. 3 times 100 is 300. So it's going to work. But I always suggest double checking it. So this right here is your answer when it asks you to use sigma. Okay? So this was your answer to that one. This was your answer to number 7. Okay? Alright, number 9. Ah, this one looks a little different, doesn't it? We've got fractions. We've got our pluses and minuses are changing on us. So let's see what's going to happen here. We've got to determine, well, what kind of function is this exactly? What's going on here? Okay. I know it's not arithmetic because I'm not adding the same thing every time to go up, but looks like I might be multiplying the same thing. Let's do our next term divided by previous, 1/9, divided by negative 1/3, and then negative 1 over 27, divided by its previous term, and then 1 over 81, divided by its previous term. And let's see what we're going to get. Now remember, dividing by a fraction means you're multiplying by the reciprocal. So 1/9 times negative 3 is going to give me negative 1/3. Negative 1/27 times 9 is also negative 1/3. 1 over 81 times negative 27 is also negative 1/3. So this is a geometric series, and r is equal to negative 1/3. So what I'm going to do is I'm going to use my formula a sub n equals a sub 1 times r raised to the n minus 1. And I'm going to figure out a formula. Well, my first term is negative 1/3. R is also negative 1/3 to the n minus 1. Now we're going to separate that exponent of n minus 1 and make that negative 1/3 to the n divided by negative 1/3 to the first power. Okay, so when you do that, you're going to divide these two terms out because they don't have an exponent of n. Well, negative 1/3 divided by negative 1/3 is just 1, and I'm just left with negative 1/3 n. Yes, I know you probably could have looked at that and you would be able to tell that that would be your function. That's going to go right here. Okay, but they're not always that easy to look at, so I wanted to show you that you could use a sub n to help you out. Okay, alright, and n is going to go from 1 to dot 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 dot. That means infinity right there. And this is your sigma notation for number 9. Okay, alrighty. So let me see here. Got just a couple more things to tell you. Okay. Oh yeah, got one more here. All right. Write this using sigma notation as well. Okay. And again, we've got a fraction going on here. And while ago, what I could tell is the top of my fraction in number 9 was always 1. It wasn't changing. But here, the top of it is changing. So what you can do here is you can find an a sub n formula for the top of your fraction and find an a sub n formula for the bottom of your fraction, and then you can figure out what your sigma is going to be. I'll show you what I'm talking about. Look at just the numbers at the top of your fraction. 1, 2, 3, 4. Of course that's arithmetic. Okay, because you're adding 1 each time, right? And again, you can probably get a sub n without even doing this. But again, I want to show you that you definitely, if you're ever in a bind, you really cannot figure out the pattern. You can't figure out the function. use your a sub n formula. It will help you. Okay, now we're just doing the top of the fraction. Okay, the first term in the top of the fraction is 1, and our difference is 1. We're going up by 1 each time, right? So a sub n equals 1 plus n minus 1. The n's cancel, and if you figured out that the top of your function is n, then you are exactly right. Okay, now the bottom, going up by 1 again, right? But this time you're starting with 2. That changes things. Okay, so my first term is 2, and I'm adding 1 each time, so my difference is 1. So a sub n equals 2 plus n minus 1. So the bottom of my fraction is going to end up being n plus 1. Now that makes sense to me. I'll show you why. Here's your sigma. Okay, the top of your fraction we're going to use n. The bottom of your fraction we're going to use n plus 1. Okay, now start n at 1. Okay, if you let n be 1, you're going to get a 1 on the top, a 2 on the bottom. That's your first term. If you let n be 2, you're going to get 2 at the top and a 3 on the bottom. That's your next term. Okay, and then so on. Well, this does not have a dot, dot, dot. That means this right here cannot be infinity. That would be wrong. Okay, you've got to figure how far it's going to go out. Okay, well, the top is n, 1, 2, 3, 4, so it looks like this is going to go to 4, and this is your answer. Okay, now you have some properties at the front of your workbook in Unit 7 that's in Edmodo. Okay, and these first two right here, these are properties, and I forgot to jot down that here C is a scalar. Okay, also known as a coefficient. Okay, but if you are trying to find the sum using sigma of some function a, and it has a scalar or a coefficient in front of it, as I goes from 1 to n, you can pull that scalar out in front of sigma and just simplify this part, and when you're done with this part, multiply it back by whatever c is. And I'll show you what I'm talking about if you don't quite get that. Okay, if you have a summation of a function that has more than one term, say you have an x plus 2, or say you have an x squared minus 8, okay, then what this property says is you can give each term of that function its own sigma. And again, I will demonstrate that in a minute. Okay, then we get to these properties that you have to know. The state test will not give you these formulas. It's very few formulas that the state test gives you. Okay, and these are not 4 of them. You have to know these. Okay, these are shortcut formulas. If you're doing the sum of a constant, C is a constant, okay, as k goes from 1 to n. Say you're saying 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2. C is 2. C is your constant. You're going to do that n times. Well, you're just going to multiply 2 times n, or c times n, whatever that number is. I will demonstrate. You know I will, so keep a smile on your face. You're going to get this. It's not as bad as it looks, okay? Sum of your integers. So this is your notation for the sum of your integers, because k is changing from 1 on out to n. So that means k is 1 plus 2 plus 3 plus 4. See, you're adding those integers, okay? Well, a shortcut to finding that sum is just take whatever n is, plug it in here, and say n times n plus 1, and then divide it by 2. Okay? Same thing here. This is the sum of your squares. So this is the sum of 1 square plus 2 square plus 3 square plus 4 square. Here's your shortcut formula, as long as you know what n is. Okay? And you'll know what n is. It'll be given to you. Okay, sum of your cubes, this is the sum of 1 cube plus 2 cube plus 3 cube plus 4 cube, and so on. Okay, the sum of your cubes, if you notice, is really the same as your integers, but you're going to square it. So a lot of times, some students like to leave it this way. Some students like to go ahead and square each one of those factors. Square the n plus 1, and square the 2. Okay? You can do whatever you want to, but here we go. This is how we use this. This is not bad. This is actually pretty easy. Okay? We're going to take this step by step. Okay? I'm going to write down every tiny little step that you have to do. And you'll decide, you'll start seeing where there's some steps you can condense, okay? First thing I notice is I have a 2k minus 1, okay? And I have two different terms, so I'm going to separate this using this property right here that says if you have more than one term, you can separate the terms and give each term its own sigma. That's the first thing I'm going to do. So I'm going to write this as the summation of 2k as k goes from 1 to 25 minus the summation of 1. Okay, I'm not going to put a negative there because I already took care of that minus right there. Okay, so the summation of 1 as k goes from 1 to 25. Okay. Next thing I notice is this k right here. It has a coefficient or a scalar. That's this property. It says if that happens, take that scalar, pull it through in front of your sigma. So that's what I'm going to do. I'm going to pull that 2 through sigma and rewrite this as 2 times the summation of just k as k goes from 1 to 25. And this one does not have a variable or anything, so I'm just going to bring that down. Okay, so that was using my properties. Now what I can do is I can use my formulas, but I'm thinking I want to make this problem a little bit more interesting. Let's make that 1 a 3. Don't y'all love erasing? Don't y'all love when the teacher just decides, let's change this problem. Let's just do it. Let's change it. Let's make it so much more fun. Okay? And let's make it even more fun. Let's throw in a k-square in there. There we go. So now we have another term. So let's add on to this and put plus the summation of k squared as k goes from 1 to 25. See, now this problem, it is so much more fun. Yes, it is. Yes, it is. Yes, it is. Okay, here we go. So now we're going to apply formulas. Okay, here we go. All right, this part right here, it doesn't use n, it uses k instead, which is fine. You know how we are in math. We like to change things up sometimes just to see what you're going to do. Okay? But that right there, when it says the summation of k, oh, I did give it to you in terms of k. Oh, I'm so good. Okay? Summation of k as k goes from 1 to some number is this formula. I'm going to write that formula down. Okay? So the formula that I'm going to use right here, and I'm going to bring that 2 down, but right here in the place of this, I'm going to put the n times n plus 1 divided by 2. Now in a minute, in my next step, I'm going to replace that n with 25. Okay? Now here, this is the sum of a constant number. Look at your formula. Sum of a constant number. Right there it is, okay? If you're doing the sum of a constant number, you take that constant and you multiply it times whatever n is, okay? So that's going to be 3 times n, and yes, n is 25. I'll replace it in just a second. And then here, this is the sum of k squared, the sum of your integers, okay? Come back over here, look at what that formula is. The sum of your integers squared, not integers, but sum of your integers squared is n times n plus 1 times n plus 2. I'm sorry, n times n plus 1 times 2n plus 1, and all of that is over 6. So that's what I'm going to put in the place of this right here. N times n plus 1 times 2n plus 1, all over 6. Okay? So now what I'm going to do is I am going to replace all of these n's with 25, and I'm going to simplify this problem. Would y'all like me to sing you a little song? You want a Christmas song? Have yourself a merry little Christmas. I know y'all love my singing. Not. Okay. Alright, so I've replaced everything. Well, these 2's right here are going to cancel. A little mental math here. I know that 25 times 25 is 625 because 25 squared, I have that memorized. 25 6 would mean there's an extra 25 in there, right? So shouldn't that be 650? Y'all check it on your calculator. Email me if I got it wrong. Okay. Minus 75, because I am not going to pick up a calculator for this problem. Not going to do it. Not going to do it. Okay. I just multiplied 25 times 26, didn't I? Okay. And I got 650. So that's going to be 650 times 51. 0, 5, 6, 0, 5, carry my 2, 3, 2, 0, 5, 1, carry that 1 is 3, 3. Ooh, I hope that is right. Okay, so 3, 3, 1, 5, 0, all over 6. I wonder if that divides evenly. 3, 3, 1, 5, 0. Again, tell me, just email me if I got it wrong, okay? Alright, I'm trying my best not to make any careless errors, but at the same time, I try not to make these video lessons too long for you, okay? I forgot to put my 5 up there, didn't I? That is so funny. 6 and 33, 5 times 6 is 30. Bring it down. 6 and 31 is 5 again. 5 times 6 is 30. Subtract 6 into 15 is 2. That's 12. Subtract, I get 30. That's going to be a 5. So 650 minus 75 plus 5, 525. What's 650 minus 75? Would that be 575? Plus 5525. And what is that going to give me right there? 6100 maybe? I hope so. You can check it, okay? And tell me if I'm wrong, because I'm sure you will. I know how y'all like to be with me sometimes, okay? But that's okay. Correction is not rejection, right? Right. Okay. So this was a fun little lesson. Enjoy it. And we'll talk about it in class.